I had a couple students request a system of equation practice problem during our review today. So here's one that was given to us last week, and I'll talk through my approach, how I would try to solve this system without a calculator. I think it's worthwhile to have a game plan before you start doing any work, and from what I can see here is that row 2 and row 3 are going to combine nicely. If I add row 2 with row 3, it's going to get these x variables to cancel, and I'm going to be left with an equation that contains just y and z. And if I had an equation that contained just y and z, it would be helpful to have another equation that contained just y and z. But I don't have that in row 1. But if I did combine row 3 with row 1, so if I took row 1 plus row 3, I would get pretty close. All I would need to do is double row 3. If I multiply row 3 times 2, then I'd have a 2x here that would cancel with the 2x at the top. And then again, the x's would be gone, and I'd have an equation that contained just y and z. And from there, I can then solve the remaining system of equations. So let's take a look at what that might look like. So here we go. Row 2 and row 1, if I strictly add those two together, negative x plus x cancels, they add to 0. Negative 3 plus negative 5. Now this takes a little bit of mental math, but I'm sure you can handle it. Negative 3 plus negative 5 is negative 8y, and z plus 4z is 5z. 9 plus negative 3 equals 6. So I'm going to call this my A equation because that's the result that I got from row 2 and row 3 being combined. I'm going to create a B equation, and this B equation will combine with A so that we can isolate one more variable in the next step. Now that B equation is going to come from doubling row 3, and I have to double everything in row 3, and I'm actually going to show this off to the side. So row 1 looked like negative 2x minus y minus 3z equals 18. And if I double row 3, everything in row 3 becoming doubled, I now have 2x minus 10y plus 8z equals negative 6. Now when I combine these two, this would be the result of row 1 added with 2 times row 3. Again, the x's cancel. Negative y plus negative 10y, call that negative 11y. Negative 3z plus 8z is 5z. And 18 plus negative 6 is 12. And so now I have an A and a B equation that can be combined, and it looks like the z variable will cancel if I combine these two. Now when I combine them, I'm not going to add the two rows together. When I combine these, I'm actually going to subtract them, and that's perfectly fine. A minus B is the same as A plus the opposite of B, which is a legal move in row operations. So I'm just thinking to myself, what's going to happen when I subtract these two? Well, negative 8 minus negative 11, that would be the same as negative 8 plus 11. That's 3y. 5z, take away 5z, well those cancel to 0. And then 6 take away 12 is negative 6. Now we have 3y equals negative 6. If I divide both sides by 3, I see that y is equal to negative 2. And we've got one of our solutions. We can now back substitute into either one of these equations, A or B, and we can now solve for the letter z. I'll just use that top equation. Negative 8 times y, which we know is negative 2, plus 5 times z equals 6. So we have 16 plus 5z equals 6. 5z then is equal to negative 10. And z is equal to negative 2. And of course, now that we know that now that we know that y and z are both -2, we can back substitute in one of the original expressions. Doesn't matter which one of these three, and we can solve for x. I'm going to use the third equation, x minus 5 times -2 plus 4 times -2 equals -3. So x plus 10 minus 8 equals -3. If I subtract 10 and add 8, that'll place me at -5 for x. And now we have a solution to the system of equations. We could report this solution as a ordered triple and call it -5 for x, -2 for y, -2 for z. Or if you want to leave your answers separated like this, that would be okay too. But that's my technique, that's my approach for problems like this, anytime that we have to solve a system by hand without a calculator. Again, I try to isolate or eliminate one variable, I should say, not isolate. But I eliminate one variable that seems obvious at first, make modifications to another row to get that same variable to disappear, and then I repeat that process with the remaining equations that have one fewer variable to work with. I hope this helps. If you have further questions, please let me know.